Okay, it's on. So in chapter X has 5. Let's go. Question number 1. Three lines form the sides of two squares. The equation to the fourth side of the. Okay. Let's look at the lines. X plus 2y plus 3 equal to 0. X plus 2y. Wait, the same thing. X plus 2y minus 7. So these like are parallel, and then 2x minus 5. Oh, that guy is perpendicular to these two. The equation to the fourth side of each square. So there's like two squares, right? Because two parallel, one perpendicular. There's like two possibilities for the other one. So what would this other fourth perpendicular thing would look like? It would look like 2x minus y equal to c, right? Okay, cool. So 2x minus y equal to c, that would be that line, and 2x minus y equal to 4, that is the already given perpendicular line to us. So the distance between these two, that will be c minus 4 upon square root 5. What's the distance between the two lines which were already given parallel to us? That would be 10 upon square root of 5, right? So c minus 4 should be equal to 10. So c should be equal to 14, I think. Yeah. So if c is equal to 14, then the other side would be no mod of c minus 4 equal to 10. So it's 14 or it's minus 10 plus 4, which is minus 6. So it's 2x minus y plus 6 equal to 0, or 2x minus y minus 14 equal to 0. That's it. That's the two fourth sides. Question number 12. Wait, just question number 1, right? It's question number 2. A is given. AB is any line cutting through the x-axis in B. AC is perpendicular to AB and meets the y-axis in C. AB is any line cutting through it, cutting the x-axis. Any line, right? In B. And then AC is something like this, and then it's cutting the y-axis at C. Equation of the locus of the midpoint of BC. Let's just say that this guy has slope m. Then how do you find the y minus what's y? It's just 0 in this case, because yes, 0 minus 1 upon x minus 1 equal to m. So x is 1. Well, it's like any 1. So x is 1 minus 1 upon m. Right, that's what this x is. What about this y thing? So y minus 1 upon 0 minus 1 equal to negative 1 upon m. So y is 1 plus 1 upon m. So now we got these x and these y things. This guy is just the midpoint of this complete thing. So it's just x upon 2, y upon 2. That means this is negative 1 upon 2, negative 1 upon, okay, negative 1 upon 2m, and 1 upon 2 plus 1 upon 2m. So as you can see, add them up, just get 0. Wait, that's 1 plus that. Oh, this should also be 1 plus that, right? I thought so, because this, it does not look like it has y plus x equal to 0, right? Or it could be like that, like x equal to negative. It's not that it cannot be, but it just doesn't look like that's the slope. So I'm gonna go with this. So it's x plus y equal to well, now it's 1 by 2 and 1 by 2. So x plus y equal to 1. Cool. Next, question number 3. Okay, we don't want this pen. Cool. Now okay. Distance of the point from the line measured parallel to this line is. First of all, for finding the distance, what I'm going to do is I'm going to find the feet of perpendicular from that point to this line. Yeah, because that will give me the vector going from the point perpendicular to the line and then I can figure out what that vector's component is along the line along which we have to measure the distance. Hopefully this will work. Let's see if it does. So x minus 2 upon 3 equal to y minus 5 upon 1 equal to, okay, so 2 times of 3, that's 6 plus, okay, 5 plus 4 so upon a square plus b square is like 9 plus 1, but negative, everything's just negative. Yes, this will be negative 15 upon 10, which is negative 3 upon 2. And that means, oh, you don't actually need to know what x and y are. You just need to know what x minus 2 and y minus 5 is, because then you know the vector, basically. So x minus 2 is negative 9 upon 2, and the other thing is negative 3 upon 2. So these are the vectors. Right, this is the vector, and we want this to be measured parallel to this line. This line has, okay, it's along this vector, which is 4 comma 3, I think, and then divide by 5 to make it a unit vector. So this is the vector along this line, I think. Yes. And I just want to find what is this vector parallel. Yeah, along this vector, it's not that hard. Just dot product these two, so it's going to be minus 36 upon 10 minus 9 upon 10, which is negative 45 upon 10, I think. 9 upon 2, yeah. So is this correct? Just check once again. When you put 4, yeah, like if x naught y naught satisfy 3x minus 4y plus 8 equal to 0, then x naught plus 4t and y naught plus 3t, those also satisfy this equation. So yeah, that's cool. And then this guy is of course just that a square plus b square. It's not square root of a square plus b square, is it? I don't think so. Yeah, I don't think that's square root of a square plus b square. Come on, remember something. Yes, it's not that. It should be just a square plus b square, and that is 9 plus 1, which is 10. Yeah, everything's nice, I guess. So it's negative 9 upon 2. Yep. So we don't want negative, we just want the magnitude, which is 9 upon 2. There we go. What could go wrong, right? What could go wrong? They're parallel to that. Yes, it's all correct. Question number 4. Perpendicular from the origin to the line joining the points divides it in the ratio. Look at these points. These are on a circle. A circle centered at the origin with radius c, right? So, oh, this is very, very stupid because, yeah, from the center to the chord, if you draw a perpendicular, that will also bisect it. And that means it's in the ratio 1:1. That's stupid. Question 5. Image of this guy in this line, that's just calculation. So it's it's x minus 1 upon 1 equal to y minus 2 upon 2 equal to, so negative 2, right? Yes, negative 2 times of 1 plus 4 plus 5, which is 10 upon 5, because 2 square plus 1, that's 5, yes. Negative 4, there you go. So x is negative 4 plus 1, which is negative 3, and y is negative 6 plus 2, which is negative 4. So it's negative 3 comma 84. There we go. That's the thing. Where was I? Question number 5. Let's go to question number 6. Length of segment cut off from the line, this line, between these two lines, okay, is draw this. So y equal to 3x is like this, and x equal to 3y, that's like this thing. And then this line is just this. So you just want to find these 2 points and be done with it, basically. Some other way to do this thing, maybe. Is there any other way to do this? I don't think so. I mean, you could be finding vectors and stuff, and you know what this distance is, right? You know what this distance is, and you know what these angles are, right? I mean, you can figure out the slopes like that. Yes. So from that, you can figure out what. Oh, it's not that bad, in fact. So just first of all, just find the distance of this origin from this line. What was the line really? Just 3x plus 4. Where did it go? 3x plus 4y equals 12, right? So for 0, 0 it's like 12 upon 5. So this distance is 12 upon 5. Draw a neat image. This is the thing. 3x plus 4y. So y is smaller, x is bigger, something like this. Then since y equal to x, this is y equal to 3x, this is y equal to 1/3 x. We don't want this. Right. You know what this distance is, right? Well, what would this slope be really? It's 3x plus 4y. So negative 3/4 would be this slope. So 4/3 would be the slope, right? And yeah, what's this distance? This distance is 12 upon 5. What's this angle? Call this thing angle as alpha. Call this thing angle as beta. Okay, I'm not sure if this is going to work really. Will this actually work? No idea. I mean, you just know what the intercepts are. Why not use those? Because that actually won't work. Yeah, you need to know what these angles are. Man, this is just too complicated. Not worth doing. It's just not worth doing. Go by the calculation method. Okay, what was I doing? Question number 6. Right, just find the points and find the distance between them. So let's start. So when you have 3x plus 4y equal to 12 and x equal to 3y, then that means when you put it inside, that just becomes, oh, what am I doing? 13y equal to 12. That means x is 36 upon 13. So that point, that's just 36 upon 13 and 12 upon 13. Similarly, when you put y equal to 3x in there, when you put y equal to 3x, you will have 3x plus 12x, which is 15x equal to 12. So x equal to 4 upon 5. Then y will be 3 times of that, which is 12 upon 5. So it's 4 upon 5, 12 upon 5. You got the 2 points. You just need to find the distance between them. Before finding distance, let's just actually simplify a bit and I don't know, make the denominators common, right? So multiply by 5 on top and it's like 180 upon 5 upon 65, sorry, and 60 upon 65. Multiply by 13, 13 times 4 is 52. 13 times 12, that's like 144 plus 12, which is 100. What's 144 plus 12? That's 156. Okay, so now you got these 2 points, and now we can find the distance. It's like 1 upon 65 square root of these two guys, difference of that. Yeah. So that will be 8 and okay, 128 squared. The difference of these two. that will be 96. Wait, really? Come on, what am I doing wrong? 144 plus 12. This is 156, and this would be 96. Yes. That's weird. So it's 96 squared, huh? And that will be 1 upon 65 times. So anything common in between these? I think 8 is common. So 8 square root of 1 and 3 squared plus 1 and now 4 is common. So 32 upon 65 square root of 4 squared plus 3 squared. Oh, that's just 5. So this is 32 upon 13. There we go. 32 upon 13. That's the answer. Okay, next. Question number 7. The area enclosed by this thing, x minus 1, mod of that is equal to. Okay, I hate these mod things, but just have to open them up somehow. So, okay, when x is bigger than 1, you will have to break it in 4 processes. Sorry, 4 cases. Yeah. Okay, think about it. This is 0, 0. 1, 3 is somewhere over here. You break it into 4 different sections, right? Over here, it's x is bigger than 1, y is bigger than 3. That means this thing is just x minus 1 plus y minus 3 equal to 1. So that's going to be x plus y equal to, oh yeah, equal to 3 plus 1 is like 4. So x plus 1 equal to 5 something. Wait, is this for real? Yeah, it's x plus y equal to 5. So when x is 1, y is 4. And when x is, it's somewhere over here. 1, 3, and this would be 4. Okay, and when y is 3, x is 2. That would be somewhere here. So this is this line, and let's look at this guy. Actually, no, first let's look at this guy because it's the opposite of that thing. X is less than 1, y is less than 3. So this would be x plus y minus 4 equal to negative 1. So x plus y equal to 3, I think. Right. You know what? Skip all of this. In fact, because like we can shift the whole coordinate system to this point, so why even worry about doing this? Instead, yeah, why do all of this? Instead, if you just want the area, which is not related to coordinates anyhow, just look at these things. Mod x plus mod y equal to 1. That's much easier. So yeah, like x plus y equal to 1. This guy is like x minus y equal to 1. Yeah, I think so. It's like y equal to x plus 1. Yes, that is x minus y equal to 1. This is minus x plus y equal to 1. This thing is negative x negative y equal to 1. Cool. And what's this thing? This is 1, 1. This would be square root 2. This would be square root 2. The area is just 2. Question number 8. Two mutually perpendicular straight lines through the origin form an isosceles triangle with line. Once again, the area of the triangle. So you don't have to worry about the coordinates, right? So they only gave us a line and a point and told that the other two sides are perpendicular to each other. That's all they told us. From that, what can you get such that no information is lost? Just the distance between that point and the line. And what's that distance? The distance is 5 upon square root 5, which is square root 5. So this is the origin. You got square root 5 distance from this line. Then you draw two sides which are going to form this isosceles triangle, and those are also perpendicular. Yeah, and there could be also this other way of drawing it, like, oh, like this, and then this would, yes, no, it can't be, because this angle will never be 90 degree. A triangle can contain at most 190 degree, right? So it can only be this. Then this thing is 90 degree, that means this is 45 degree, and this thing is 45 degree. So yeah, well, this being square root 5, that means this is also square root 5, this is also square root 5. Oh, we got it, we got the area. Half of 2 square root 5 times square root 5, which is 5. There we go. Okay, question number 9. If the quadrilateral formed by these lines have perpendicular diagonals, okay, prove that this condition is true. What are these sides? Ax plus by plus c equal to 0, a dash x plus b dash y plus c. Oh, the same constant, huh? Same constant. Okay, next line is ax plus by plus c. Wait, what? This is ax plus by, and this is also ax plus by. And the fourth has a dash b dash. This is also a dash b dash. Oh, so these two, like this guy and this guy, these are parallel. And then similarly, this guy and this guy, these are parallel. Okay. What's the distance between these? Oh, sorry. Yeah, like these two. That's just c dash minus c upon, yes, upon square root of a square plus b square. And then this guy is having distance. I mean, these two people have distance. Once again, c dash minus c mod everywhere. So what is this? It's just a parallelogram with like these distances that we figured out. Okay, cool. And what is this? Like, you want these to have perpendicular diagonals. Oh, perpendicular diagonals. When does that happen? When does you have? Wait a second. Perpendicular diagonals. Come on, man. Think of it. A parallelogram having perpendicular diagonals is just a rhombus. So this is a rhombus, and how are the distances between these two related to it anyhow? I mean, that's all you actually have. Yeah, seriously. Because you know nothing about the relation between a dash, b dash, and ax, and a and b. So you only know these are two parallel lines with some distance between them that we can calculate, and these two are with some known distance between them. That's all they gave you. Okay, and also that this is a rhombus. Oh, if it's a rhombus, huh? Then that means if this angle is theta, then okay, wait. This angle is theta. These two sides are equal, right? And this angle is also theta. And look at this. This thing is just this side times sine theta. Okay, cool. That's what this distance is. What about this distance? Well, this is also theta, right? This times that. Oh yeah, that's cool. So because these two sides, like all of these sides are just equal, these two distances are also equal. These two distances are equal. Yeah, that means the distances that we calculated, those are equal. That's cool. For that to happen, these two quantities must be equal. Got it. So it's just a proof question. We did it. Question number 10. A is a point on either of the two lines. This is two lines. Okay, so mod x is 5. Right, got it. So try to graph this even better, in fact, even better. Square root 3 by 2 mod x plus 1 by 2 y. Look at this, it is very similar to something I've seen. So it's like mod x y, this vector dot square root 3 by 2 1 by 2. This is a unit vector, by the way, equal to 1. That's what this really is. Oh, you know what? Yeah, that's like a plane, but in 2D, that would just be a line. Huh. Okay, where was I? Uh, okay. Try to graph. So at least think on one easy point that would be on this. Yeah, it's just this thing. Copy this. Okay. When x is positive, this thing will be x, right? And that means square root 3 by 2 and 1 by 2. That's a point on this line. This distance is 1, and everything that has this distance 1, that will work, right? So this distance must always be 1, and it will work because this is the component of this vector along this, and dot dot only deals with that thing. So you got that. Okay. Cool. And similarly, when x is negative, this would be negative x, and y, or maybe I could say x y, just keep it as xy, but then negative square root 3 by 2 and 1 by 2, that thing is equal to 1. Oh, then this would be this thing, something like that. Hey, when it's square root 3 by 2 and stuff, you know it's going to be 30 degree, right? And this would be 30 degree as well. So just two lines like these. This is 1, this is 1. Cool. This thing is 60 degrees, right? Yeah, it's also 60 degrees. And what are they asking? The coordinates of the foot of perpendicular from A on the bisector of the wait, sorry. A is a point on either of these two lines at a distance of 4 upon square root 3. 4 upon square root 3. Oh, units from their point of intersection. This is the point of intersection. How much is this distance? I mean, this is 1. This is 60. It should be 2, right? Similarly, this guy will be like, I mean, this is 1. This thing is 30. Okay, this is tan theta and stuff. What was I doing one second? This is 30 degree. This is going to be 2 upon square root 3, something like that. Right. And what about this thing? Okay. This distance is square root 3 because tan 60 degrees square root 3, and this is like 1 upon square root 3. So now you know everything about these triangles. Yeah, and you just want a circle with radius 4 square root 3 and something. You know, this angle is 30 degree. That's it. That's all you actually need to know. You need to know what this is, what this is, what this is, and what this angle is. You got everything. So this would be 4 square root 3. This complete distance combined, what would that be? That would be square root 3 plus 1. Shit, that's 4 upon square root 3. Oh. So this circle is actually cutting like this. Then what am I asking? Foot of perpendicular from A on the bisector of angle. Bisector of angles is the y-axis. So this is the origin basically. 0, 0. Right, 0, 0 is the answer. Okay, next question number 11. The points are opposite vertices of a rectangle. The other two vertices lie on the line y equal to 2x plus c, and the other vertices and c are okay, 1, 3, 5, 1. A rectangle. Y equal to 2x plus c runs through both of these actually. Okay, what that means is that it also passes through the midpoint of these two, right? What is the midpoint of these two? It's just 3, 2. So putting that into that thing, what's this? Y equal to 2x plus c. 2 equal to 6x. Wait, x is, sorry, is it 6? It's just 6 plus c. So c is minus 4. So this line is really just y equal to 2x minus 4. Okay, and what do they want to find? What about this thing? So this would be x and 2x minus 4. Parameterize this, right? And then we just need this to be 90 degree. Okay, it's not that bad, right? So this should be 90 degree, then that means uh, y minus is like 2x minus 7 upon x plus 1 into 2x minus 5 upon x plus 5. This thing should be negative 1, right? Which is like 4x squared. Negative 12 times 2 is like negative 24. X plus 35 is x squared. Oh, it's negative 1. So plus 4 and 2. And what was y? Which is 2x minus 4. So y would be, when x is 2, this is 4. When it's 4, it is, wait. When x is 2, it's 0, sorry. When it's 4, it's 4. Yeah. Now it's correct. So the points are 2, 0 and 4, 4. Okay, cool. Question number 12. Yeah. B and C are fixed points having coordinates this respectively, the vertical angle B. I've done this kind of question once, I think, right? Laws of centroid, they ask you. So the radius before everything was it's 90 degrees, right? So like these are diametrical points. The radius originally was 3, and now for the centroid it's 1/3 of that, right? So this is 1. That makes x squared plus y squared equal to 1. The SAT of set of values. The set of values of P for which the origin and the point lie on the same side of. Okay, fine. So if it's positive, then the point should also be positive and stuff like that. The origin, well, it's obviously positive because these two cancel, we just get 1, right? So that point 1, 1, that gives us a squared plus ab plus 1 upon all of that stuff, like square root of a power 4 plus a squared b squared stuff. Forget about that. The thing is that this thing should be positive for it to be on the same side. So what do you want from that? Oh, for all a belonging to real. Okay, that means discriminant is less than 0. So b squared minus 4 is that's 4. Yeah, because 1 and 1 less than 0. B is bigger than 0. So like b is less than 2 in that case. Bigger than 0, less than 2, because yeah. So 0, 2, that is the range of b. Consider the point this and that. If p be the point of line y equal to x, is that pa plus pb is minimum. Actually, just graph this. Question 14. A is 3, 4 like this, and this guy is 7, 13. Oh, that's pretty big. And then you have y equal to x, which would be something like this. Okay, so this thing is A, this thing is B, right? And P is just some guy on this, and what you want is that this should be the, I mean, this plus that should be minimum. Triangle inequality, but okay, this cannot actually lie between A and B, and that's why triangle inequality kind of fails, because you cannot get that minimum that you want. Something else. Oh, you can do this thing. You can just take the image of A, right? And then use the triangle inequality, because this distance is the same thing as that distance. So this plus that's bigger than or equal to this thing, and it will be equal to if P is somewhere over here. Oh, so you just need to find what this A dash is, and then find this line and find the intersection point. That's a lot of work. Let's start. Question number 14. So it's going to be x minus 3 upon y equal to x. Oh, y equal to x. Look at that, how lucky we are. So this thing is 3, 4. This thing would be 4, 3. Right? The reflection. There we go. And b we already know is just 7, 13. What's this line? It is y minus 3 upon x minus 4. You will third must like 10 upon 3. So 3y minus 9 equal to 10x minus 40. So 3y equal to 10x minus 31. And now for the intersection point, y equal to x. Putting that in this, you get 7x equal to 31. So x equal to 31 upon 7 and y equal to x, so it's the same thing. So 31 upon 7, 31 upon 7. That is the point P. Alright, next question. If this point lies in the region corresponding to the acute angle between the lines, range of A is acute angle. Okay, I get it. Question 15. Graph y equal to half x, y equal to 1/4 x. This acute angle region, this point lies in there. So the slope must be between these two slopes. That's it. Just 1 upon a less than 1 upon 2 less than 1 upon 4. So a less than 4 bigger than 2. 2. So 2 comma 4, that is the thing. Question number 16. If the algebraic sum of the distances of the points from the line y equal to mx plus c is 0, then the line will always pass through a fixed point whose coordinates are. So question number 16. Oh, we have done this kind of things before as well. So sum of distances, just get rid of the bottom, the denominator thing. Don't think about that, just think about the numerator. It's gonna be what, 2 plus 3 plus minus 4, which is minus, okay, just 1 times whatever the question of x is, which is just m. Then for it will be like mx minus y plus c, right? So for y, we minus. For y, it's 1 plus 2 is 3. Okay, plus 7, which is like plus 10. And then there's going to be 3 c's, in fact. So plus 3c upon, okay, forget about that. It's just 0. Look at that. 1 upon 3 m minus 10 upon 3 plus c equal to 0. So that means 1/3 comma 10/3, it always passes through this point. That's it. It always passes through the line. Got it. Okay, let's check the answers. Question number 16. Oh, well, that's nice. And 4 and okay, that's nice. Very nice. Yeah, the same stuff. Huh? Wait, question number 12. Then question number 8 is 5. Okay. Cool. -6. Why is this -4 over there? And that's different. Okay, wait. What did you? Oh, okay, I see. So 2 times -4 is -8. Plus 2 is -6. So it's not -4, it's -6. It is wrong. Question 4 is 1. I don't know. 5 of. Why should. Question number 3. What was question number 3? Okay, so you just found the point of projection. So it's 2 upon 3. Yeah. So y minus 5 upon 1. Okay, equal to 5. And let's say if it is 15. So minus 15 upon 10. It's minus 3 upon 2. Right. Yes, that's very correct. And so now you know what these vectors were, just -9/2 and -3/2. And you just want that vector's component along that line. That line has this vector. Yes, that is correct. And what's going wrong? Not sure. The calculations also look correct. What could possibly be going wrong? I don't know. Okay, I'm just gonna give it a round and move on. Question number 2. Oh yeah, that's what I want. So that's it. I'll see you guys in the next video.